electronic configuration describes the distribution of electrons in an atom. Previously, you know that fluorine has the electronic configuration of 2.7. We will learn another two ways of writing electronic configuration known as SPDF notation and orbital diagram. According to the SPDF notation, number 1 represents shell number 1, 1s represents subshell 1s, and the number 2 means that the 1s subshell contains 2 electrons. Based on the example, for nitrogen, there are 2 electrons in 1s orbital, 2 electrons in the 2s orbital, and 3 electrons in the 2p orbital or subshell. Orbital diagram. In this example, nitrogen has 3 subshell, subshell 1s, subshell 2s, and subshell 2p. A box represents an orbital. Therefore, 1s has 1 orbital, 2s has 1 orbital, while 2p has 3 boxes, each representing 2px, 2py, and 2pz orbitals. The arrows represent electrons. The different direction of arrows represent the different spins of the electrons. Electrons are assigned to orbitals based on these 3 rules: Aufbau principle, Pauli exclusion principle, and Hans rule. To Aufbau's principle, electrons occupy orbitals with lower energy before they occupy orbitals with higher energy. Based on the diagram on your right, orbitals with the lowest energy is 1s orbital, followed by 2s orbital, then 2p, 3s, 3p, 4s. You follow the arrow at the diagram until you reach the orbitals with highest energy. Pauli exclusion principle. No 2 electrons in an atom can have the same 4 quantum numbers. As an electron can only contain 2 electrons, the 2 electrons must have opposing spins. That means if one is assigned positive half, the other must be assigned negative half. Hans rule. When electrons are added to orbitals of equivalent energy, for example 2px, 2py, and 2pz, orbitals are filled one by one with electrons of the same spin before they are paired. Now, we will look at how all these three rules are applied when writing the electronic configuration of the element chlorine, which has 17 electrons. Electronic configuration of ions. A metal loses electrons of the outermost orbital to achieve stable electronic configuration of the noble gas. For example, sodium loses electron in the third shell to become sodium ion with only 2 shells, same as the electronic configuration of the noble gas neon. Configuration of anions. A non-metal gains electron into the outermost orbital to achieve stable electronic configuration of noble gases. For example, sulfur gains 2 electrons to form sulfur ions, which has 8 electrons in the third shell, similar to the noble gas argon. Zinc has 30 electrons. In the following animation, we will see how the electrons are arranged in all the orbitals from 1s, 2s, 2p's, 3s, 3p's, 4s, and finally 3d orbitals.